Imagine floating in the silent, infinite darkness of space, gazing out at the familiar pattern of Orion. The constellation stretches across the cosmic canvas, its stars twinkling like ancient beacons. But one star, perched on Orion's shoulder, burns with a deep, ominous red, a celestial warning light in the night. This is Betelgeuse, a star that has fascinated and mystified humanity for centuries. Your eyes are drawn to Betelgeuse, a red supergiant so colossal that, if it replaced our sun, its surface would swallow Mercury, Venus, Earth, and even Mars. Its diameter is nearly 1,000 times that of the sun, and its volume could fit over 1 billion suns inside. Betelgeuse is a true titan, a dying giant whose every pulse and flicker is a message from the edge of stellar existence. For generations, Betelgeuse has been a constant, a familiar beacon in our sky. But in recent years, astronomers and stargazers alike have noticed something unsettling. The star's brightness, once steady, has begun to fluctuate in ways never seen before. Its surface roils with convective storms, vast plumes of gas erupting and falling back, creating a restless, unpredictable pattern of light and shadow. Betelgeuse is nearing the end of its life, burning through its nuclear fuel at a furious, unsustainable rate. Deep within its core, the star fuses heavier and heavier elements, each stage bringing it closer to a cataclysmic finale. The energy unleashed in these final throes is immense, driving the star's outer layers to expand and contract, to pulse and dim, as if Betelgeuse itself is struggling to hold on. Its fate is sealed. Someday Betelgeuse will explode in a supernova, unleashing more energy in a single instant than our sun will emit in its entire lifetime. When that day comes, Betelgeuse will outshine the moon, casting eerie shadows at night and becoming visible even in daylight. But the real question, the one that haunts astronomers and excites skywatchers, is when? Is the end near, or will Betelgeuse linger for centuries more? In late 2019, the world watched in awe and anxiety as Betelgeuse began to fade dramatically, losing over 2/3 of its brightness in just a few months. This unprecedented event, now known as the Great Dimming, sent shockwaves through the astronomical community. Was this the first sign of the impending supernova, or was something else at play? The Great Dimming captured the world's imagination. News outlets ran headlines speculating about the star's fate. Social media buzzed with excitement and fear. Amateur astronomers pointed their telescopes skyward, hoping to witness history in the making. Was this the beginning of the end for Betelgeuse? The world held its breath, waiting for answers. Across the globe, people gathered to watch the night sky, united by a sense of wonder and anticipation. For many, Betelgeuse became a symbol of cosmic mystery, a reminder that even the most familiar stars can surprise us. Early observations with ground-based telescopes suggested that a massive cloud of dust ejected from Betelgeuse itself might be blocking its light. But the true cause remained elusive. Was it dust, or was the star itself undergoing dramatic internal changes? The mystery deepened, and astronomers knew they needed a new way to see through the chaos. To unravel the enigma, scientists turned to infrared astronomy. Unlike visible light, infrared can pierce through dust, revealing the hidden workings of stars. But even the best telescopes on Earth were limited. The answer would have to come from space. Enter the James Webb Space Telescope, the most powerful observatory ever built, designed to peer deeper into the universe and further back in time than any instrument before it. With its golden mirrors and cutting-edge infrared sensors, Webb was perfectly suited to study Betelgeuse's turbulent atmosphere. With Webb's unprecedented vision, astronomers are now peering into the very heart of Betelgeuse's chaos. They can see the swirling storms, the plumes of gas, and the intricate dance of dust and light that defines a dying star. Each new image and spectrum is rewriting what we know about the final stages of stellar evolution, offering clues not just about Betelgeuse, but about the fate of all massive stars. The stage is set for a cosmic drama unlike any we've seen, a story of death and rebirth, of mystery and revelation. As Betelgeuse teeters on the brink, the universe holds its breath and we watch, awestruck, waiting for the next chapter in the life of a giant. The James Webb Space Telescope's infrared vision cut through the dust, revealing Betelgeuse as a chaotic, dynamic system. Webb saw massive plumes of gas, larger than our solar system, erupting from the star's surface. These weren't gentle winds, but violent convulsions, flinging stellar material into space. Imagine a pot of boiling water, now scale that up to a star 20 times the sun's mass. Webb showed that Betelgeuse's surface is a seething sea of giant plasma bubbles, each bigger than our sun. The Great Dimming? Webb confirmed a chunk of the star's surface was blasted into space, cooling and forming a vast dust cloud. That cloud drifted between us and the star, causing the dramatic fade. For the first time, we could trace the dust back to its violent origin. This wasn't a simple stellar birth. It was a staggering event that challenges our models of how giant stars die. Betelgeuse isn't shedding its layers gently, it's convulsing, reshaping its environment. We're witnessing a star fighting its own gravity, creating a complex nebula around it. The view is both beautiful and terrifying. Webb's data is transforming our understanding of stellar death. Webb's discoveries go deeper than dust and gas. They reveal the hidden forces inside Betelgeuse. Powerful magnetic fields twisted by the star's churning surface may drive these violent eruptions. When these tangled fields snap, they unleash energy, launching plumes of material far into space. The dust cloud from the Great Dimming isn't static, it's evolving, changing as it drifts away. Webb can analyze its chemistry and temperature, showing how the building blocks of planets are forged in a dying star's final moments. Elements from Betelgeuse are being seeded into the galaxy, ready to form new stars and worlds. We're watching this cosmic recycling in real time. The violence of the Great Dimming was far beyond what we expected from red supergiants. Betelgeuse's core may be more unstable than we thought, sending shock waves to the surface. Webb lets us witness this turmoil with stunning clarity. The Great Dimming put Betelgeuse in the spotlight, sparking wild speculation about an imminent supernova. But as more data came in, a clearer picture emerged. We didn't witness a star about to explode, but a massive surface event. The star itself didn't dim. Our view was blocked by a colossal dust cloud. Imagine sand thrown between you and a spotlight. The light is unchanged, but your view is obscured. This surface mass ejection explains the dimming and the star's later brightening. Crucially, it separates surface drama from the core processes that trigger a supernova. The Great Dimming was a shedding of skin, not a failure of the heart. Scientists now see it as a rare chance to study a giant star's outer turmoil up close. It forced us to rethink how chaotic and unpredictable a star's final years can be. The event gave Webb a perfect target, deepening our understanding of stellar evolution. Sometimes a cosmic misunderstanding leads to profound discovery. So, is Betelgeuse about to explode? The answer? Probably not. Webb's data shows violent surface activity but no sign of an imminent core collapse. Betelgeuse is in its twilight years, but those could last thousands more. Astronomers estimate a supernova within the next 100,000 years, a blink in cosmic time, but not in ours. We can't peer into the core to know exactly when the end will come. The key takeaway? These discoveries revolutionize our understanding, but don't set a doomsday clock. Scientists urge us to marvel at the spectacle, not fear it. We have a front-row seat to a rare stellar drama, thanks to Webb. Sleep easy. Betelgeuse isn't detonating tonight, or likely in our lifetimes. The timing remains one of astronomy's great mysteries. Webb has given us insight, not a warning, reminding us the universe keeps its own schedule. The investigation into Betelgeuse is just beginning. Astronomers worldwide are watching, using every tool available. Webb will revisit Betelgeuse, tracking changes in its atmosphere and dust. Each observation adds to the puzzle, refining our models of stellar life and death. We're moving from snapshots to a feature-length film of a star's final act. The lesson? Humility and patience. The cosmos unfolds on its own timescale. Webb's discoveries excite not because they warn of disaster, but because they reveal the universe's complexity. Even familiar stars hold secrets, waiting for the right questions and tools. Next time you see Orion, remember, Betelgeuse is a colossal, turbulent furnace reshaping its corner of the galaxy. It's a laboratory for stellar physics, and a reminder that the journey of discovery is as spectacular as any supernova. The real wonder is in looking up and daring to understand.